name's Elliot Petty. I'm a senior hydrologist and hydraulic modeler at Jacobs. Used 2D modeling quite a lot throughout my job over the last sort of 7 years, so hopefully know a bit about 2D modeling at this point. Today I'm presenting about 5 tools in Flood Modeler to boost your 2D modeling. So these are 5 tools that I think are particularly useful, and hopefully it will give you guys some ideas in your own 2D modeling, give you an idea of what Flood Modeler can do. So what are the 5 tools that I'm going to cover today? Well, first one's topographic adjustment. Second is embedded structures, so embedding 1D structures in a 2D model, and then also covering 1D 2D linking tools, so automating that process. If you've got lots of runs to set away, batch simulations, and then if you've got sets of results and that kind of thing, some mapping tools to apply some context to that. But before we get onto those, I just wanted to add in this slide to highlight some key resources and formats, really. You can see there's two links at the bottom there. The knowledge base and the YouTube channel. The knowledge base is Flood Modeler's help system. It has all sorts of technical guidance, and if you press a button in Flood Modeler, what happens next? What kind of equations is it using? All that kind of thing. So if you're looking for more detail, that's the place to go. I'd also recommend the YouTube channel. Really useful videos on there, lots of sort of how-to guides, so step by step, and you can pause it and play it as you want to step through those things. Just to highlight as well in the formats that we're talking about 2D modeling, lots of different layers and different elements to 2D models, heavily reliant on GIS to build these models, which is really to highlight that Flood Modeler can use a range of GIS formats. So if you've got shape files, I think it can handle tab files as well, and various standard raster formats, sort of ASCIIs, FLTs, TIFFs. Got a bullet point at the bottom there, looks a bit random, but roughness. Often get questions about roughness, so you can draw on things like OS master map, different sort of roughness sources to apply into your Flood Modeler models. So yeah, it's quite a flexible bit of software. If for whatever reason you have data not in one of these various formats, you might want to consider using the API to convert these data. API is a relatively new feature in Flood Modeler, but if you have your own little Python scripts and that kind of thing, you can draw on the Flood Modeler API to kind of integrate Flood Modelers as quite powerful features really into your Python scripts and that kind of thing. So it's if you're into that kind of automation of modeling processes, APIs for you. But the key message here really is that Flood Modeler can do everything you kind of need it to build a 2D model and a 1D model. So it's one software to do everything. So you don't really need to leave Flood Modeler to build your models. So anyway, let's get on to the first of the 5 tools that I was planning on talking about today. The first is topographic adjustment, and that kind of really boils down to 2 different features in Flood Modeler. One is the topographic features tool, and the other one is the Z mods tool. Topographic features tool is there for sort of applying single levels, so blanket levels across individual features, so single levels. ZMod is a little bit more flexible. Perhaps you have lots of different levels across a single feature or that kind of thing. So I'm going to present a demo on the ZMod tools shortly, but just to sort of introduce, lots of software can do topographic adjustment. So what's so special about Flood Modeler, I suppose? Well, it's actually really simple to apply topographic adjustments. You don't really need a lot of knowledge about GIS to do it. You just need to know about the workflow. But that simplicity isn't really a trade-off against the flexibility of its application of the tool. You can represent lots of different topographic features. I've listed a few there, enforcement, removal, embankments, walls, finished floor levels, etc. I could probably spend the next half hour going through different examples that Flood Modeler could apply topographic features for. So yeah, really flexible tool, but actually quite simple to use. And you can just adjust existing features really quickly as well. So if you've got existing sort of elevation, shape files, that kind of thing, really easy to adjust those. So anyway, I can say this on a PowerPoint, can't I? Put it on some bullet points, and you take my word for it. But I might as well actually show you what that looks like. So just to quickly introduce you to the workspace that you'll see a few times during this webinar. Here I've got a 1D model. So hopefully, if you were listening to Georgina's webinar last week, you'll actually be slightly familiar with this if you haven't seen a Flood Modeler 1D model before. I've got a 2D floodplain here, DTM, but it's not perfect. I want to make some adjustments to it. So I'm going to go into here and just have a look here. We've got our floodplain on the right hand side here. and I happen to know this is a railway embankment along here, so I'm going to take a look at this, and I've got, there's an opening here through this railway embankment, but I perhaps want to enforce that, that opening. So I'm going to use my ZMod tools, and here we go. I'm on my 2D build tab. Loads of different features in here that you can use to help you build your 2D models. I'm going to use the ZMod polygon tool today. I'm going to save this somewhere. So as soon as you click that button, it's asking you to save a shapefile, and I've got a nicely organized folder structure here. So I'm just going to call this ZMod for example's sake. And that appears in here now, so it automatically loads in, and then I'm going to draw my polygon. I'm just going to keep it nice and simple, so left click to start, double click to finish. There we go. I don't really like the color of that, so I'm just going to right click and go to properties, symbology, give it a different visual style. So let's give it a nice clear color and change transparency a little bit. There we go. So at the moment this is completely blank. It's not actually applying any levels. So let's give it some levels. And I'm going to use the ZMod vertices tool here. So instead of creating a separate shapefile and drawing individual points onto this shapefile, actually I'm just going to use this ZMod vertices tool, and it will draw those automatically. Now I actually want to flatten this bit of embankment here in my 2D model, so I'm going to draw levels from my DTM, nice and easy, click and drag, and I'm going to replace all values. I'm going to use height. So if I process that, it's going to create a new shapefile. You see there that new snap points. If I go to properties, let's see what kind of levels. Let's investigate the levels that it's applied here, and I go to height and apply that. It's a bit of a dark color. I can't really see that too well. There we go. And maybe I'll offset that a little bit as well, so you can see it a little bit easier. So it's really simple. That's it for creating a modification of this type. Really, really straightforward. Let's just, for example's sake, just add this into my XML file, so my simulation file. So domains, you can see here, I'd already done it as a test. It's the same kind of process. So I'm going to add a ZMod. If I add this from my existing, I'll highlight both of these. Another bit of a description here. Embankment removal. Always good practice to label your 2D modeling features. You can see there, it's been added straight away. So really easy, really, really easy to add this kind of thing. I don't want to save this because I'm going back to the PowerPoint. So yeah, it's a really easy thing to do, really simple, but again, doesn't really trade off with the kind of flexibility of the application of the tool. You can do quite a lot with it as well, but as I say, really simply. So moving on to something a little bit more complicated. Quite often when you're building a 2D model, you might want to integrate 1D elements in some form. So kind of making the best of both worlds. Like 2D modeling is typically best at certain things and 1D perhaps better at others, or certainly easier to understand than equivalent in 2D perhaps. So you often kind of merge the two together to get like the best of both worlds. Maybe you have, in the case I'm going to show you in the demo, we've got a culvert through an embankment, or through the embankment I just showed you. If you imagine sort of trying to build a 1D model of that, it's such a small feature. You build a separate 1D model, a separate 2D model, and link the two together. Quite frankly, it's a bit of a faff. It's a bit of a pain to do that. And you have to draw link lines and all that kind of thing. It gets a bit laborious for such a simple feature. But the embedded structures tool for modeler takes a lot of that effort away. It's really easy, really easy to draw these kind of features. So you don't need to develop, using the embedded structures tool, you don't need to develop a whole separate 1D model to add 1D elements to a 2D model. The way it works as well means it's more stable than linking separate 1D and 2D models, and can simulate a wide range of flow conditions. So if you're familiar with 1D modeling, often need initial conditions of some kind, but in this case you don't. It's just a case of create the feature and run your model. It can run completely dry and run fully submerged as well. So really, really quite useful. But equally, it still draws on the same really good stuff from the Flood Modeler 1D in terms of some structures are quite complicated. You need to apply quite a few parameters or levels, that kind of thing. So it's useful to have a wizard to step you through the schematization of those structures. And that's exactly, it just draws on it's exactly the same as the Flood Modeler 1D wizard. It just draws on those tools, on those windows. So again, I'll show you how that looks. So I've got my topographic feature here of I'm going to enforce that on on the embankment here. But perhaps there's a culvert further down here somewhere. Let's have a look. Maybe you can see a slight channel here. So just eyeballing it, perhaps there's a culvert that runs through the embankment here. We can't quite, it's not being captured by the LiDAR because the LiDAR should bounce straight off the embankment. So I'm going to add a 1D structure. So I'm not going to go to any of these 1D tabs to do that. I'm sticking on the 2D build tab. You can see here on the left-hand side, we've got 2D model section of the 2D build tab, and I'm going to click 1D structure. So let's add a new embedded structure. So again, just call it embed. You might want to give your features something a bit more of a descriptive name. But I'm just trying to give you guys an idea of what full model can do. So if I just draw from across here and say that's where the culvert is. So again, left click to start, double left click to finish the feature. It's really quite simple to draw it. So that's my structure added. But then I want to specify what kind of structure this is. And then if you just click the edit 1D structures tab while still editing this layer, you end up with this window here. And I'm going to click these ellipses to see which kind of structure I want to add. So I'm going to add an orifice unit today. I'm assuming this culvert is quite short and the barrel losses aren't significant. Just want to represent those entry and exit losses. So I'll press OK. And you can see in here we've got a length of 0 because there's no length of the culvert, but because it's an orifice unit. But if you draw a line across here, and you are drawing on the length, then the length can be from the line, or you can define it yourself. You can include a bend. And if I double click on this, so if you've familiar with full model 1D, this unit might be familiar to you. The orifice unit opens up exactly as the 1D unit does. It applies exactly the same equations, operates in the same way. It's just the way it's linked to the 2D that's different in terms of the 1D 2D linking. So I'm going to give this a bore area because if you don't, it won't close. But I'm not going to fill this in. But you can use Flood Modeler's sort of 2D tools. You can interrogate the LiDAR using profile tool and that kind of thing. If you've got survey, you can use that to inform all these levels. So yeah, really useful tool, really quite powerful and simple. So now I've defined everything that need to. It's saved it here. It's saved the edits that I made. I'm going to stop editing now. So it's done. That's it. And then again, to add this into your 2D sort of simulation file, again, just open up your simulation file, go to 1D structure. You can see here I've added one in already. I want to remove it because I'm going to add a new one. Yes, and then press add. And then I can go find this. Oops. So if I didn't expect that, apologies. So if we can just add this in here, and then we've got this as well. So here we go. Click and drag. I should have just done it the simple way. You can see it's kind of spitting back at us the attributes that I'd added in the edit. Recognize my shapefile here. Beauty of this is you can get separate outputs for your 1D components, your embedded 1D components, so you're not reliant on the outputs from the 2D. So if you wanted to perhaps you wanted to investigate your 1D feature in more detail, you can change the save intervals to get maybe more frequent outputs. Maybe you want specific parameters such as wetted perimeter or your hydraulic radius, those kind of things that kind of only be relevant to channels that you often represent in 1D. So yeah, really quite flexible and quite easy. So there we go. It's added my embedded structure. Apologies, I was trying to add a ZMod tool into an embedded structure. Funny thing, doing things live on a webinar do to you. But yeah, embedded structures added there, and press save. It's quite easy as well. And you can see there when I press save, nice neat little feature. It's full model is telling me that 2 file paths aren't valid. So I've added something somewhere that can't find, and it's very helpfully telling me that that's the case before I try and run my model. So embedded structures, whistle stop tour through embedded structures. Again, really useful tool, much easier than adding a full-blown 1D, 2D model. But if you have to, Flood Modeler does have its own sort of 1D, 2D linking tools. The link line generator is a way you can automate the process of linking 1D, 2D models. Really useful. Not just in the way that it sort of automates that process, but actually the mechanics of Flood Modeler's 1D, 2D linking is very good. One feature to consider both link type, and elevation. Rather than having multiple files, snap things together, getting a bit complicated just to create a 1D, 2D 1D 2D link, using the link line generator tool allows you to automatically populate those attributes as well, so elevation and link type, and that all goes, as I say, goes into one file. And you can define things like levels, so the elevation. So maybe you have cross sections that you've truncated, 1D cross sections that you've truncated to top of a bank, and you can want to snap your 1D 2D link line to that. You can do it. Perhaps you've received shape files from a surveyor, topographic surveyor, of maybe, I don't know, bank crest levels, and you want to snap your link line to that. Then link line generator is a really useful tool for doing that. So if I go back to the demo workspace, here we go. If it'll let me, thank you. And if I pan across the left here, you can see I've got 1D network. It's quite a long river here, lots and lots of nodes. So perhaps I only want to link part of this. So I'm going to go hit over, staying on the 2D build tab. You can see here I've got this river 1D 2D link lines sort of section. You can see on the right hand side of that we've got various link types. Not going to talk about those today, got a limited amount of time, but the key one here is this big button, this river 1D 2D link line generator tool. Super useful. I'm about to show you why. Click that button, up pops a window. It's recognized that I've got a 1D geometry file in Flood Modeler, this stat file, and that's what I want to use today. I'm going to use the active portion because these cross sections are truncated to top of bank, as I suggested earlier. I'm only going to link the right bank, quite a flat floodplain on the right bank, but in the left bank, I'm thinking there's a bit of elevation here. Maybe just represent it as extended 1D sections. I'm going to import elevation data, and I'm going to use the 1D section elevation. So assuming that the cross sections elevation taken from a surveyor is more accurate than the LiDAR. I'm going to stick with the level link, and then I've got these adjustment factors, A and B. They're basically calibration factors. I've got no reason to change those at this point. I'm just drawing the line for the first time. So I'm going to draw this line between 2 points. So let's define the first 1D node labels. This is like your upstream node label. So I'm going to go with Coldo 1 00092. Let's find that. It's a big 1D model, so bear with me whilst I scroll through this. Here we go, found it. And then going further down, go to call W02 00394. And again, apologies, just bear with me. Here we go, found it straight away. And then we're going to create a new link line. And again, I'm going to separate this out into a separate folder and give it a not very descriptive name for example's sake. There we go. So just double check that I've got everything that I need in here. Appears so. If you wanted to, again, you can click this button. It's recognized as a shapefile in here. You can trace that instead, but again, I'm going to use the cross sections and only the active portion. Press OK. And let the modeler work its magic. You can see here it's drawn a link line. You're thinking, how does it know where to draw this line? But it perhaps becomes a bit clearer if I click and drag the data file into here. And you can see how it's snapped to the edge of your cross section, which is perfect. Really what you want to see when you're drawing a link line like this. But notice how it is it's interpolating between nodes. So it's just going from one 1D node cross section to the next. It's not necessarily sort of looking at the LiDAR, understanding where the embankment is. So perhaps you maybe want to make a change to this, but again, it's not too difficult. So I just right click and start editing this. Got various vertices. So I'm going to add a vertex here, for example. If I just highlight this section of link, add the vertex. Again, move the vertex around. Really easy to do. And then I'm going to save that. And you can imagine, I've done this on a small section of watercourse, but if you can imagine a really big model where the pain you go through trying to manually link these kind of things, especially if you've got multiple layers and you're reliant on snapping to get something to work, knowing the pain of snapping errors popping up when you first build a 1D 2D model. This tool is really useful. You won't get those kind of issues, and really speeds up the process of building 1D 2D models. If you have to, you might even just need your embedded structures. So going back to the slides now. We've got the 1D, 2D links. So yeah, hopefully you've seen how useful they are. I use this quite a lot. It's really useful for linking Fluid Modeler 1D and 2D models together. So you've built your model, you've got your embedded structures, you've added your topographic modifications, you've linked your 1D and 2D together. Maybe you have a whole bunch of simulations that you now need to run. Fluid Modeler's also got some tools to help you do that. You can run your simulations in batches, so you can monitor the status of several runs at once in a single window. It allows you to kind of optimize the use of your computer hardware. So when one simulation finishes, it will automatically move on to the next one to allow you to get your results quicker. And depending on your licensing arrangement, you can run up to 4 simulations concurrently. Also on this slide, just got a quick shout out for the GPU, Fluid Modeler GPU solver. Really useful solver. You don't need to change anything about your model particularly to get your GPU solver to work. It's literally just changing the click of a radio button to change from CPU to GPU. No changes to parameterization or anything like that. It's really quite simple. And then some really brief metrics at the bottom there to show kind of the benefits of using GPU over CPU. That being said, the CPU solver is not exactly slow. It's still quite rapid, especially for smaller models. So yeah, really just a bit of a plug for the GPU solver there. Really useful, especially you can see the time reduction on that for particularly long models. So we've got a 1-day CPU model of 1 million 2D cells running in 30 minutes, which is pretty incredible. So I'll just show you what the batch simulator actually looks like. If I go to my batch runner here. So I've got, this is a separate Fluid Modeler project. I've got various models in here. I think there's a 2D GPU model, a 1D urban model that's completed, and currently, awaiting to start 2D GPU 1D urban model. You can see in here we've got the three runs in these windows. So if you're familiar with running Fluid Modeler models one at a time, this is the same window that appears when you do that. But we've got 3 of them here all side by side, and you can manage them quite easily and get your details on how this is all gone. So key metrics, listed out in the table here: mass balance, mass error, really important metric. Are we gaining volume or losing it in an unexpected way? Can it not be accounted for? Is the model running? When's it going to finish? How's it performing? And you can do that across lots of different runs. So it's really quite useful. I should say, briefly going back to this slide, I should add the conditions under which we have run the GPU solver here. Has used quite a powerful graphics card, but that being said, Fluid Modeler's GPU solver can use any NVIDIA card. It can be an integrated card. So long as it's NVIDIA, it will work. So really good, really flexible. And then moving on to the fifth and final tool to I really want to highlight today, which is the online services. So Fluid Modeler draws on a whole bunch of data from external sources, and you can add those into your project. So it's a single bit of software to load in all of your data. Really useful. It's not drawn from a Fluid Modeler server, it's drawn from the source. So for example, maybe if you're based in England and you're interested in the Environment Agency, perhaps you're doing an FRA of some kind, and you're looking at flood map for planning, so flood zones 2 and 3. Fluid Modeler can draw on the DEFRA, the Environment Agency sort of services or server to draw that information, the most up-to-date information off that server. So it ensures you're getting, as I say, up-to-date information. That comes from a WFS or WMS source or sort of type of information. So depending on your internet connection, you might want one or the other, or if you don't need attributes, you might just pick WMS. So you get tiles, or if you want the proper shapefile with all the attributes behind it, you might want WFS. But the key thing here, no additional licensing required. You don't need to set Fluid Modeler up in a particular way to allow this to happen. So it is just a case of clicking some buttons, as I will show you. So here we go. I want to load in. So go back to the Home tab. So I'm disappearing off from the 2D Build tab and going to the Online Services. Here we go. I'll click this button. Going for the UK today, and I'm going to pick the Environment Agency. I'm going to load in 2 flood zones here. Press Add. Just give it a second. It is going all the way across the internet to recover this data, and here you go, all loaded in. We've got our flood zones here. If I just untick these, you will hopefully be able to see underneath. So really useful to be able to add all these in. I should say, actually, I forgot to mention about the batch simulations. If you want to find those, go to the simulation tab and go to run batch. So just jumping back a slide there. Yeah, hopefully you can see how these are all quite useful tools in building a 2D model, and how quickly I've done this. This webinar is only half an hour. I've already added at least 3 of sort of key elements of a 2D model really quickly. Appreciate when you do it, you might want to do it with a bit more consideration, but just demonstrating that these tools are very easy to use, very flexible, powerful, and maybe the tools you want to think about in building a full modeler 2D model.